Hi, this is Dr. Kraus with another quick Raspberry Pi tutorial. I want to talk about Raspberry Pi pin numbers, or the GPIO pin numbers. And the issue is there's at least two, if not three, conventions. If you were to Google Raspberry Pi GPIO pin numbers, this is a pretty good article, the first one that comes up, at least with my Google settings. And it talks about there's two main conventions that everyone recognizes. One is to use the actual physical pins on the Raspberry Pi. The other is to use the pin numbers of the BCM Broadcom processor that's at the core of the Raspberry Pi. And so those two conventions don't always agree with one another, and they actually, at one point in a revision, if you follow some of these along, some of the pins actually moved from one revision of the Raspberry Pi to another. Thankfully, they seem to be mostly have kind of nailed in on what they want that connection to be. And so the 2 and the 3 both have the exact same pin. I think even the 1 A plus or B plus might also have the same pin out. And so these circles here would be the Raspberry Pi physical pin locations, and then some of these would be the numbers of the BCM Broadcom module pins. So know that convention. And then the thing that gets even trickier is if you then were to Google WiringPi pin numbers. Because of this confusion, the author of WiringPi decided, well, I'll just make my own virtual pin numbers. And I kind of think that's a good idea, but it seems like that may have caused even more confusion. So if you Google WiringPi pin numbers, it takes you to wiringpi.com/pins. And so this is kind of only done for maybe the model, the one lower model numbers, but these header numbers are the Raspberry Pi physical pins. The names are the name of the pins as they're connected to the BCM, and then the BCM GPIO numbers are the chip numbers, the BCM numbers, and then WiringPi pins are virtual pins that start at 0 and just go up in increments of 1. So for example, WiringPi virtual pin 0 is the same as Raspberry Pi physical pin 11, which is also BCM GPIO pin 17. And the settings in WiringPi allow you to choose which of those three conventions you want to follow. So I'm going to show you here in a second is pin 0, if I go with the virtual pin setup, is the same as pin 11 if I go with the WiringPi physical pin setup, is the same as pin 17 if I go with the WiringPi BCM GPIO setup. So I know that that's super confusing, and I had to prove it to myself. So I'm going to show that 1, 11, and 17 and the three different conventions are the same. I'm sorry, 0, 11, and 17 are the same pin in that convention, different conventions. Or WiringPi pin 1 is also physical pin 12, is also GPIO pin 18. And WiringPi pin 3 is physical pin 15, is GPIO pin 22. And WiringPi pin 4 is physical pin 16, is GPIO pin 23. And so we'll try these different cases here shortly. So all of that is well and good as long as you know where is pin, if you knew where pin 1 and 2 are, you can kind of count the pins from there. So I want to talk through that really quickly. So I took the case off of my Raspberry Pi 3, and you can see that the USB pins are ports over here on the left. The pin 1 is on the opposite side, the far right side of the board, and 1 is on the inside of the board, 2 is on the outside. So this is 3, this is 4, this is 5, and here's a ground on Raspberry Pi physical pin 6. And so in this example, I've got 7 and 8, 9 and 10 empty. And then physical pin 11 is this white cable, 12 is a gray, purple is 13, 14 is empty, and 15 physical pin is the blue. So going back to the code a second to see the correspondence there. If I can slide this over and get this on the screen at the same time, I've got physical pins 11, 12, 13, and 15 populated. So 11, 12, 13, and 15. And 6 is my ground, and that corresponds to this. Unfortunately, you'd have to rotate that to get the pins in the right location, but you can see that the ground is pin 6, GPIO 17 is 11, GPIO 18 is 12, so on and so forth. And that corresponds to these numbers here. GPIO 17, 18, 27, and 22. 17, 18, 27, 22. So that's all in agreement. So it's, I don't know why there's these different conventions. I don't know what these things mean, but this all works. And so the way that we're going to verify that those are the different conventions that you can choose from is I've got a set of LEDs hooked up to those ports. So ground is over here, and then each of these different wires is coming to a different LED. And this is a really, really simple circuit, which if you just Googled LED circuit or something, I assume you'd come up with something pretty similar. And the basic idea is that you have the plus 3.3 volts coming off of the WiringPi pin here, and then it's running through a resistor and then going to ground. And if you don't have the resistor, then when this thing is forward biased, the LED is essentially a short, so this thing is emitting light. I think that's usually how they show an LED. And normally, if you Google this, you're looking at 200 to 300 ohms. I didn't have any 200 to 300 ohm resistors laying around, so what I've actually got is two 1000 ohm resistors in parallel, giving me an effective resistance of 500 ohms. And so that is my circuit. I feel like this cable's kind of in my way here a little bit. Sorry about that. And what I want to show with some of my code is this is pin 0 in WiringPi virtual pin numbers. This will flash once, this will flash twice, this will flash 3 times, this will flash 4 times, and then we'll show that in the different cases this continues to behave exactly the same. So if I can slide this over and show you first case 1, and you'll see it'll print out case equals 1 that we're using pins 0, 1, 2, and 3, and then we'll see the flashing. And I don't know how to, I got to make this all fit on my monitor simultaneously. There we go. And for reasons we'll discuss in a later video, I've got to shut down IPython every time or WiringPi gets mad at me. So watch for the 1, 2, 3, and 4 flashes. And you can see over here on the code that it printed out case equals 1 and that we're using pins 0, 1, 2, and 3. And so if you look at the code, case 1 does exactly that, and then so case sets up which of these 2 functions or 3 functions we call and what the pins are, and then it prints that out. And then we'll do a little, this is basically a for loop in WiringPi. So for I, comma pin in enumerate. So enumerate is a way to do a for loop, but you also get, so each time through the loop, pin takes on one value of the elements of this list pins. So in this case, it would go 0, 1, 2, 3, and then I would be the corresponding index. So it would go 0, 1, 2, 3 as well. Not so interesting in case 1, but in case 2, pin would take on the values 11, 12, 13, and 15 each time through the for loop. Well, I would still take on the values 0, 1, 2, and 3. And so I'm then flashing 1, 2, 3, or 4 times, depending on the value of I, by writing the pin high for half a second, then writing the pin low for half a second. Okay, so let's quickly verify that if I close this, I change to case 2. I didn't mean that. And then I come back over here, I start IPython again, and I got to do a sudo because WiringPi requires super user abilities, so remember those things. So sudo IPython and then run this code and see 1 flash, then 2 flashes, then 3 flashes, then 4 flashes. But now case is equal to 2, so we're using pins 11, 12, 13, and 15. And then if I shut it down, and come over here to case 3. Now we're going to use the GPIO BCM pin numbers of 17, 18, 27, and 22. But in terms of these wires, we still see 1 on the white, 2 on the yellow, 3 on the red, and 4 on the green. So I know it's confusing because it confuses me. You can choose to use either of these 3 functions to choose which pin convention you want to use, and then you either choose 0, 1, 2, 3, 11, 12, 13, 15, or 17, 18, 27, 22, and you've got to know what that means in terms of your physical pin connections. And like I said, part of the answer is to go to WiringPi pin numbers and look at this somewhat confusing table. But WiringPi pin 0 is the same as physical pin 11, is the same as BCM GPIO 17. WiringPi 1 is the same as physical pin 12, is the same as GPIO pin 18. WiringPi 2 is the same as physical pin 13, is the same as, and this is where in revision 1 of the Raspberry Pi, apparently that was BCM GPIO pin 21, now it's GPIO pin 27. And then WiringPi pin 3 is physical pin 15, is GPIO pin 22. So hopefully that makes sense. And between this table, which again is on wiringpi.com/pins, between this table and this example code, using the 3 different functions and the 3 different conventions, you can make sense of how I connected those 4 wires to Python, again using either the WiringPi virtual pins, the Raspberry Pi physical pins, or the Broadcom GPIO pin numbers. Thanks.